Hello there. So we're going to move on to naming hydrocarbons. Okay, so if you remember from the previous class, what are hydrocarbons? Hydrocarbons are those that are only made up of carbon and hydrogen. So if you look at the first thing here, you see this word here, saturated, and you see another word that says unsaturated. Now basically when we talk about hydrocarbons, right? So hydrocarbons, if you remember from the previous class, carbon makes four bonds, right? Carbon makes four bonds. So what at the end of these bonds usually for hydrocarbons would be hydrogens. Okay. So you notice that in every one of these examples here, carbon is bonded using four single bonds. So we call this to be saturated. That means saturated means completely filled up. Okay. But when you see a hydrocarbon, let's say if we remove these hydrogens here and you see a double covalent bond anywhere in the structure, then we call it unsaturated. So which means that there is a double bond between carbon. So there can be one double bond, it can be two, can be three, can be four. When you have more than one double bond, we call this unsaturated or polyunsaturated. Okay, polyunsaturated. So when you hear this word saturated and unsaturated, basically if saturated, carbon is bonded to every other atom with single bonds, or if it's unsaturated, there is at least one carbon that is bonded to another carbon via a double bond. Okay, all right, let's move on. So hydrocarbons, so it says there can be saturated and there can be unsaturated, and there's something called aromatic. We'll talk about this later. So under saturated, there is something called alkanes and cycloalkanes, alkenes and alkynes. Okay, so these are all hydrocarbons, meaning all of these guys only contain carbon and hydrogen. Alkanes, cycloalkanes, alkenes and alkynes. Okay, so we're going to be focusing on these three first. So these are the three homologous series. I'm pretty sure maybe in high school you would have heard of this word homologous. Homo basically means the same. Logos means like family. They belong to the same log. Okay, same log. So the log here is alkane, alkenes and alkynes. Now one important criteria about all members of a homologous series is they have a general formula. You see this here? This is called a general formula. It is not an empirical formula. It's not a molecular formula. It's called a general formula. So every member of that family will have the same formula. Like for example, in this case, N is the number of carbons. So for alkanes, N can be 1, it can be 2, can be 3, and so on. Meanwhile, for alkenes, N has to start with 2. And then 3 and 4 and so on. N cannot be 1. You know why? Because for alkenes, minimum you must have one double bond. So which means that you must have at least one double bond, which means that you have to start with 2 carbons. You cannot start with 1 carbon. So the N value always starts with 2. Same thing goes with this guy here. N must start with 2, 3, 4 and so on, because for alkynes they have a triple bond between carbon atoms. Okay, so that's them. So alkanes all single bonds, alkenes at least one double bond, alkynes at least one triple bond. Okay, so minimum for alkynes is also 2 carbons. So when N is 2, let's put it into the formula, right? So when C is 2, H 2 times 2 minus 2. Okay, so you end up with C2, H2. So this is the most basic unit of alkyne. All right, the most basic unit. Are you okay with this so far? Okay, let's move on. I added this page, but I'm not going to use it yet. Okay, so when we're naming alkynes and alkenes and so on, you come across 3 things: prefixes, stem, and suffixes. Now, what you need to know is suffixes is the family name. So the family name, if you are an alkane family member, your name will end with an ane. If you are an alkene family member, your name will end with an "ene." If you are a alkyne family member, you will end with the word "ein." Ein. Okay, so this is pronounced as ein, like somebody's name Ein. All right, Ein. So ein, in, ein. All right, so that's the suffixes. So which means that if I belong to a family of alkane, I could be called ethane. Or if I'm a family of alkenes, I'm called ethene. Or if I'm a family of alkynes, I'm called ethyne. All right, that's how it is. Stem is basically how many carbon atoms are in the longest chain. So if you remember this, if you've ever done this before, you have to memorize this. So if there's only one carbon, it's called meth. So it can be methane. Okay, 2 is ethane, ethene, ethyne. 3 will be propane, propyne. 4 will be bute. If there are 4 carbons, it will be called butane or butene or butine, and that's how it goes. Okay, so five is pentagon, hexagon, heptagon, octagon, nonagon, decagon. So that's basically the concept here. Okay, so we will come across this. Suffixes are the family names. So here we go again. Ein, in, ein. All right. So prefixes, so the beginning part here you saw prefixes. Prefixes are usually commonly things like methyl, ethyl, propyl. At this moment, you may not know what you mean by prefixes. So as we go on, you will understand this better. So please remember, these are the most common prefixes that you might come across: methyl, ethyl, and propyl. Okay, so here we go. These are called straight chain isomers. Meaning later on, you see down here, right? You see later on, you'll see these funny shapes here. Oh, you see these funny shapes here? These are like ring structure, and then so these are not straight chain. So these are cyclic structures. So when you say straight chain, meaning they are straight chain. Okay. So in this case, the first thing you do is when you look at the structure, right? When you look at the structure, the first thing I want you to notice is that there is no double bond and there is no triple bond. So you know for a fact that this is an alkane. Okay, no double bond, no triple bond, alkane. So all you have to do is, in this particular case, it looks so symmetrical, both sides is the same. We start numbering. So we start numbering, let's say we start numbering, I just want to, okay, we start numbering. So we start numbering from here: 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 carbons here. If we come back to this here, we say 8 is oct. All right, so 8 is oct, and we know this is alkane, so it's going to be called octane. Okay, oct for 8 and 8. So this is the suffix, this is the stem. The stem tells us how many carbons are there in the straight chain, and you don't see anything else sticking out of this. That's it. There is no prefix. There is no prefix to be added. Okay, so let's go on to the next example here. Okay, see, in this case, look at this example here. First thing you notice is there is a double bond. Okay, you notice there's a double bond. So you see the numbering done here, it starts with this corner here, 1, and then it goes to 2, and then 3, and then 4, 5, 6, 7, 8. Somebody might wonder, okay, someone might ask this question. He said, hey, can I start numbering from here? 1, 2, 3, 4, 5, and 6, 7, 8. Can I do numbering from here? The answer is no, you cannot do that. Okay, why can't you do that? Let me explain this to you. You see, when it comes to anybody with a functional group, like in this case, this is called the functional group. Functional group. It's called a functional group. You may have heard this in high school. Functional group is the part of the molecule which is responsible for chemical reactions. All chemical reactions associated with that family member happens at the functional group. So when we do numbering, we must make sure that the functional group gets the smallest number. or the carbon which is carrying the functional group is given the smallest number. So in this case, okay, in this case, you will notice that, so we have given this carbon the smallest number. So this is 2 and then this is 3. So this is called again oct. You see there are 8 carbons, oct, and then what we do is between the stem and the suffix we put a letter 2. So this is to tell everybody, hey, there are 8 carbons in the straight chain, but the functional group in is at number 2. So it becomes oct, and between a number and an alphabet or a letter we put a hyphen, 2 hyphen again, then we put in. Okay, so when we come here, you see in this case here, what happened? Now what happened is, in this example here, it is still an alkene, it is still oct, but you see it has shifted place. From 2 it has shifted to 3, so it becomes oct. This is the name of the stem, this is the family name, the suffix, and now it's number 3. So it's oct hyphen 3 hyphen in. So whenever there is a number and followed by a word, let's say W, there must be a hyphen. So before that, if there's another word, let's say N, there must be a hyphen. Okay, so if it's a letter, hyphen, number, hyphen, letter. That's how the rule goes. Are we all right? Okay, so you see it's also written over here. Always place a hyphen between a number and a word. Okay, for example, but-2-ine, or sometimes you can also write it as 2-butyne, is the name for this. So between a letter and a number, we hyphenate. Okay, so now we come to branched chain isomers. Okay, branch. So when you say branch, right, this is where the suffix, remember the suffix just now, where we, okay, here, the prefixes, sorry, what did I say? Yeah, the prefixes, not suffix, my mistake. Prefixes come into play. Okay, let's look at the first example here. You look over here. If you look at this example over here, right, first thing you notice when you look at this, you notice that there is no double bond. Okay, there is no double bond, there is no triple bond. Okay, so this means that this is an alkane. So what we do is we try to identify the longest continuous carbon chain. For example, like in this case, it is 1, 2, 3, 4, 5. Okay. Another friend of yours might say, hey, it's 1, it is 2, it is 3, it is 4, it is 5. Another friend of yours might say, it is 1, it is 2, it is 3. Oh, stops there. All right. So there are many different ways of numbering this. So which one is correct? So we are looking for the longest continuous carbon chain. So you can go along this path, you can go along this path, you can go this path here, or you can go with this path. Either way, you get 5 carbons being the longest chain, right? So either way, you get 5 carbons. And so what we're going to do is to make life easier, we're going to stick with this. So this is our longest continuous carbon chain. Are you okay? So we start numbering. Oh, so why do we start numbering from the left hand side here? Why did I start numbering from 1, 2, 3? Why didn't I start numbering from here? 1, 2, 3. Why didn't I do that? Okay, the reason is, you see, now that I've drawn a box, you notice that there is this thing sticking out here. Do you see this? This is called a branch. So when we're numbering, priority is always given to the functional group. The functional group must always get the smallest number. But if a functional group is not present, then we go with branch. So the numbering will start from the terminal. This is terminal number 1. This is another terminal, right? This is called terminal. Terminal means the end. Okay, so this is another terminal. So whenever there's a branch, the numbering must start from the terminal where it's closest to the branch. That's why we started with 1, 2, 3. Okay. So now that we know the name is called pentane because it's 5, right? And then it's an alkane, so it's pentane. This is the branch, and then if you come back here, you notice the branch with CH3 is called methyl. So what we do is we put the word methyl, and we put a 2 to tell everybody that the methyl is at number 2. Okay, methyl is at number 2. So please remember number and letter hyphen. So now I know there is a methyl group and it's at position number 2 in the pentane. That's how we do this. Okay. Now we also can come up with the same thing. And if you notice here, how many carbons were there all together? How many carbons? 1, 2, 3, 4, 5, 6, 6 carbons, right? So if I write the molecular formula, it's going to be C6H14. Okay, you can count this out, or you can use this formula CnH2n plus 2. This is for alkane, so C6H2 times 6 plus 2, you get 14, right? Here you will notice that it's actually the same. You see 6 carbons, 1, 2, 3, 4, 5, 6, and 6 carbons, no double bond, no triple bond. This is also having the same molecular formula, same, but the structure is different, right? So when you have the same molecular formula, but the structure is different, these are called structural isomers. Okay, structural isomers, meaning they have the same molecular formula. That means the same number of carbons, same number of hydrogens, or if you're dealing with somebody else, they might have the same number of carbons, same number of hydrogens, same number of oxygens, but their structure is different. Okay, the structure is different. So let's look at this here. So let's look at this one here. Okay, if you look over here, so again what we're going to do is, step number 1 is, when we're given a structure like this, we've got to look for the longest chain, right? So the longest chain, the way I look at it, could be this could be the longest chain. Okay, some of you might say, hey sir, I think this is the longest chain for me because you're crooked, you cannot look straight, you want to look at it this way. So that's my longest chain. Somebody else might say, hey sir, I think this is the longest chain, like that. I prefer it to be drawn like this. Okay, up to you. All right, the rest of us who are straight, we want to take the easy path. When we take the easy path, we just say, you know what, this is the longest chain, it has 4 carbons. So if I go this way also 4, this way also 4, anyhow also longest is 4. Okay, so now if you notice this, there are 2 things that's sticking out here, 1, and there's another one sticking out here. So these are called branch. This is called a methyl, a CH3. This is also called a methyl. Okay, so the longest chain here is 4 carbons, so it's called butane. There is 2 methyls, so we put the word here di, like mono. We don't put mono lah. Di, tri, tetra. Okay, di, tri, tetra. I don't think you ever come across penta and so on, but di, tri, tetra. And then we are telling the whole wide world there are 2 methyls. The first methyl is at number 2. The second methyl is also at number 2. Okay, the first methyl is at number 2. The second methyl is also at number 2. So it's called 2, comma. So between one number and another number, we put a comma. Okay, 2, 2 dimethylbutane. That's what it is. Having said that, maybe we can also draw something else, right? So let's say we have a carbon, a carbon, a carbon, a carbon. So maybe we have a methyl over here, and then we have another methyl over here. Okay, now what? Okay, so let's look at the longest chain again. The longest chain for me is this. This is the longest chain. Okay, so I'm going to call this carbon number 1. I'm going to call this carbon number 2. I'm going to call this carbon number 3, carbon number 4. Somebody else might say, sir, this is carbon number 1, this is carbon number 2, this is carbon number 3, carbon number 4. Okay, I think either way it's fine. All right, the reason why we started numbering from this side was because the branch gets the smaller number 2. If we started numbering from here, let's say we start numbering from here, 1, 2, 3, the branch will get number 3. But in this example here, if I start from the left hand side, this branch gets number 2. If I start from the right hand side, the green, this branch gets number 2. So either way also acceptable. Okay, so most importantly, this is called a butane. Butane. All right, this is a butane. Okay, let's do that. And we are telling everybody, hey, there is 2 methyls here. There's one methyl over here. There's another methyl over here. So there is dimethyl. Oops, I missed that. I should have given some space. Dimethyl. And the first carbon is at position number 2. Second carbon is at position number 3 hyphen. So whichever way you want to do it, you want to follow the green, or you want to follow the red, does not matter. The answer will be the same. 2, 3 hyphen dimethyl butane. Okay, dimethyl butane. So that will be the name. So you see, in this case, this guy here, 2-methylpentane, 2,2-dimethyl butane, 2,3-dimethyl butane, all of them are having the same molecular formula, meaning they are all structural formulas of each other. Okay, they are all structural formulas of each other. Okay, you see this, you see down here, this is, they have actually done this in the notes. You've seen this here, right? 2,3-dimethyl butane. This is a structural isomer. Okie doke, that brings us to something else which is called cycloalkanes. Okay, cycloalkanes. So when we talk about cycloalkanes, we're only going to be talking about cycloalkanes. Cyclo, C-L-Y, cyclo means like a ring. Okay, so if you look at all these pictures here, they all have a ring structure. That means it's closed. It's a closed loop. Okay, ring structure. So ring. So that's what cyclo basically means. So for cycloalkanes, we are not interested in alkenes or anything like that. Only alkanes. There is a general formula here. This general formula will look familiar to you because earlier on I told you that the general formula for alkanes, did we do this here? You see, the general formula for alkanes was also CnH2n. Okay, that's a general formula. Let's come back here. So for cyclos, right, like in this call is called propane because it's made up of 3 carbons, 1, 2, 3, and we just put the word cyclo in front. So if it's 4, we put the word cyclobutane. If it's 5, cyclopentane. If it's, let's say, 8, we'll call it cyclooctane. All right, so that's basically, we don't need to know so much about this, but we just need to know there is something called cycloalkanes. All right, and we come to the last part here, aromatic hydrocarbons. Aromatic basically means, it simply means smell nice. In simple English, it means smell nice. All right, so this aromatic hydrocarbons, this is actually something which is now banned. It's called benzene. Okay, it's called benzene. Now benzene, the structure for benzene is actually this one is called the Kecule structure. Kecule, right? I don't know whether it's written here anywhere. Here, I don't see that. Okay, anyway, this is called the Kecule structure. You don't need to know this. You do not need to know this. So basically it is made up of 6 carbons in a hexagon ring like this, and there are supposed to be 3 double bonds, 1, 2, 3. So you might think that this is actually an alkene. Okay, you might think it's an alkene, and you could be right. Initially, in the early part of the 19th century, or late, around 1880s, around that time now. So this was first discovered. Smells nice, right? And when chemists did experiments with this, they kind of knew that there were double bonds, but unfortunately, it was not as reactive, or in fact, it was not even reactive like alkenes. Alkenes are very, very reactive, but so this was not reactive. So although they say, hey, got 3 double bonds, it's supposed to be very reactive, they realize it's actually not an alkene. It's a totally new group. Although it has double bonds, it's a totally new group, and they called it benzene. So you can draw it like this, you can draw it like this, or you can draw it like this. Most of the time you'll see a structure that's drawn like this with a circle in the middle. Now the circle in the middle, what basically means it means delocalized electrons. You see, okay, I'm not going to try to explain this to you, but it's not really important for you to know at the moment. In fact, it's not important at all. You see, this double bond, right? This double bond can move over here. This double bond can move over here. This double bond can move over here, right? And once the double bond moves over there, then it moves over here, then from here it can move back to here, and then from here it moves here. So it's like constantly, the double bonds are constantly moving all the time. And what makes up a double bond? It's actually electrons. So basically electrons are like jumping from here, then they jump to here, then they jump to here, then they jump to here, they jump to here. That means they are delocalized. Delocalized means they do not belong in one place. So to make life easier, scientists decided, or chemists decided, hey, you know what? I want to represent delocalized, and I'm going to do it with a ring in the middle. So that is why whenever we draw benzene, you always see a ring in the middle. It basically means, it's like, if you imagine this is like a water bath. It's like a pail, okay, like a pail, and inside of this are electrons. So it's delocalized. All right, don't worry too much about it. Okay, we're coming to the end here. So these are some of the derivatives of benzene. This is called methyl benzene. There is a methyl group here. In this case, this is called 1,2. So this, if this is 1, this is called 2. Or if you want to call this 1, this is called 2. So 1,2 dimethyl benzene. Same thing again. Okay. Yeah, that's it. All right. So if you have a benzene, let's say like this, right? Let's say this is a benzene ring structure. Let's say there's a CH3 here, and then there's a CH3 over here. Okay, and let's say there's a CH3 over here. So what we're going to call this is, so we're going to start numbering. So we start numbering from 1, 2, 3, 4, 5, 6. Okay, so this is called 1, 3, 5 trimethyl benzene. So now somebody might say, teacher, can I number it from here? 1, 2, 3, 4, 5, 6. You realize whether you go this way or you go that way, the numbering, the naming is exactly the same. Okay, so these are called benzenes, and these are some of the derivatives of benzene. You don't need to know so much about this whole delocalized electron systems and all that. You don't have to worry too much about it. Okay, so that's it. So next we'll be going into functional groups. All right, functional groups. So all the best. See you in the next video.